Hello everyone. In our last video we looked at measures of central tendency which helped us find the center of a data set. In this video we are going to look at measures of dispersion or measures of variability, which will help us find how spread out the data is. So if you're ready to get those brain cells working, let's jump right in. The first measure of dispersion that we're going to look at is the range. The range is the easiest measure to calculate, but it is also the most simple and the most limited. The range is just the difference between the highest value and the lowest value in a data set. So here we can see we have the ages of employees in a company, and the highest value here is 62 and the lowest value is 23. So the range would be 60 to minus 23, giving us a range of 39. Now notice here that I did not use the word variance or standard deviation. That's because the range does not have a unit. It's a raw number. So anytime you see the word variance or standard deviation, you know that those values are going to have the same units squared as your original data set. For example, if your data set was measured in years like these ages were, then the variance and the standard deviation will also be in years squared. Now when we use the range, we also want to use a percent of the range because the range can be skewed by outliers. You might recall from the last video that the mean and the median are also affected by outliers. However, the median is less affected by outliers than the mean, and the range is even less affected by outliers than the median. So to find the percent of the range, first find the range by subtracting the lowest value from the highest value. Next, divide each value in the data set by the range and multiply by 100. This gives us a percentage of the range. When interpreting the percent of the range, you want to look for percentages that are high. A high percentage means that that value is far away from the center of the data set. So here you can see that 23 is 0% of the range because it is equal to the minimum value. And 62 is 100% of the range because it's equal to the maximum value. But here 40, 47, and 55 are all pretty close to the center of the data set, which is the middle value of 49.5. And so those percentages are going to be low. Here you can see that 36 and 52 are farther out from the center, and so they have higher percentages. And here 28 is the farthest away from the center and has the highest percentage of the range. So when looking at the percent of the range, you want to look for the highest and the lowest percentages. Those values are going to tell you where the center of the data set is located. The next measure of dispersion is variance. Variance tells us the average squared deviation from the mean. To calculate the variance, first find the mean of the data set. Then subtract the mean from each value in the data set. Next, square each of those differences. Then find the sum of all those squared differences. Finally, divide that sum by the number of values in the data set. If you're using the formula with the sum, or if you're using the summation symbol, then you divide by n, which represents the total number of values in the data set. If you're using the formula with the product, then you divide by n minus 1. There's a whole video on why we do that. Check that out. So let's calculate the variance for this data set. First we find the mean, which is 49.5. Then we subtract the mean from each value in the data set. Next we square each of those differences. Then we find the sum of all those squared differences. And so 23 squared plus 28 squared and so on and so forth equals 590. Next we divide by n, or the total number of values in the data set, which is 9. So 590 divided by 9 equals 65.56. So the variance of this data set is 65.56. Notice that the units of the variance are years squared. Now why do we have to square the differences between the data and the mean? Well, remember that the range does not have a unit. And we don't want to just take the absolute value of the differences because that would result in negative numbers, and we want to have positive numbers. And so squaring the differences results in positive numbers. Also, squaring the differences causes the differences to be magnified. You might recall that in statistics we're usually dealing with averages and percentages, which tend to be pretty small numbers. Squaring those numbers makes them a lot bigger. which helps us visualize how far away each data point is from the mean. The final measure of dispersion is the standard deviation, which is the square root of the variance. We take the square root of the variance to get back to the original units of the data set, which is what we always want to do. So the standard deviation is calculated by taking the square root of the variance. So the standard deviation is the square root of 65.56, which equals 8.1. So the standard deviation is 8.1 years. You might be wondering why we even need the standard deviation when we already have the variance. Well, the variance is in squared units and the standard deviation is in the original units of the data set. And so it's much easier to work with. Also, the standard deviation is more common and it's preferred over the variance. There's an easy way to interpret the standard deviation. Remember that the variance is the average squared deviation from the mean. Well, the standard deviation is the average deviation from the mean. And so if you think of the mean as being the center of the data set, then the standard deviation tells us how spread out the data is from the center. Or another way to look at the standard deviation is to think of the mean as being the center of a bell curve. And then about 68% of the values in the data set will fall within one standard deviation of the mean. About 95% of the values in the data set will fall within two standard deviations of the mean. And about 99.7% of the values in the data set will fall within 3 standard deviations of t. mean. These percentages are known as the empirical rule or the 68, 95, 99.7 rule. Here we can see that the data set has a mean of 49.5 and a standard deviation of 8.1. And so about 68% of the values in the data set will fall between 41.4 and 59.6. And if we add another standard deviation above and below the mean, then about 95% of the data falls between 33.3 and 65.7. And finally, if we add one more standard deviation above and below the mean, then about 99.7 of the data falls between 25.2 and 73.8. Which measure of dispersion is best to use depends on the data set that you're working with. When the data set is skewed, then you should use the interquartile range instead of the range and the median instead of the mean. And then you should use the median absolute deviation instead of the variance and standard deviation. There's a whole video on the median absolute deviation. Check that out. But when the data set is not skewed, then you can use any of the 4 measures of dispersion. In the real world, you'll probably use the variance and standard deviation more often than the range and the interquartile range because the variance and standard deviation are used in many statistica, all tests and formulas. And that's a wrap. Thanks for watching. If you like this video, give it a thumbs up. And if you're not subscribed, click the subscribe button.